I imported the matches which were held between the 2008 to 2019. These were the first top 5 elements of the match. These were the few teams which were played during this range. As this as the CSV file has a few what we call uh, for till now a few teams have changed their name. So to I converted I replaced their older name to the newer one. Such like Daredevils has changed their name to Delhi Capitals, like with that others also. After changing the names, I showed the again. I replaced all the team's name to the short forms of the team's name. These are the abbreviations. I did just for the simplifications. It contains total 756 columns and 18 rows, and these were after replacing the variables, after replacing the teams with their abbreviations. I got this, and df.info, which tells that these are my categorical variables, and in 60 id season and dl applied, win by runs and win by wickets are my continuous variables. Next one is I am checking whether there is any null values or not. As you can see, City has the 7 null values, and it also contains umpire 1 has 2 null values, and umpire 3 2 has 2 null values. Umpire 3 also has 637 null values. I didn't treat it. I didn't treated any of them because there is no need of them. I only fill the null values in the city only, and uh, after converting it, let me show you. There are no null values. So this shows that how many times a team has won the toss, and how many times a team has won the match, and how many times a team has won the uh, tosses. As you can see, Mumbai Indians has won most of the matches, 109, and tosses also 98. So this graph, as I told in the PPT, this graph shows that how many times a team has won the tosses. Here, as you can see, Mumbai Indians has won the toss, and here also this shows that how many times a team has won the match, and this shows the Mumbai Indians has won the most of the matches. I consider team one as one, and team two as zero, and so this is where I left. So I consider team 1 as 1 and team 2 as 0. Why I considered this, I will tell you in the end. So the winner by basically this winner is converted into the binary form. After that, this is the first 5 elements. These were the unique values which were present in the team winner. I was in this. I'm just checking that venue can also be a factor or not for winning the team. So here you can see CSK has won the most of the matches. So it can also be considered as a factor also. So so those elements which are necessary for the predictions are all stored in the DF1, and these are the top 5 elements. And after that, I converted the Mumbai Indians to their numerical value so that it can be further used for predictions. Uh, all are converted and replaced the team's name with the numerical values. Uh, these are the few unique cities. There are total 31 cities, and therefore there are total 41 venues. But I converted the city to toss decision venue, which were in categorical to numericals. Using the label encoder, I used 3 label encoder objects. for the three values. First one is city, processes, and values. Why I did this? Because if we want to fetch any value, let's say one, I will get the Ahmedabad. So I can get to know that which element is converted to which number using the classes. So now I am training the models. These were the input variables: team one, team two, venue, cost, winner, city, and toss decision. This is my output winner, which is in binary form. So I imported the important modules. First one is scalar matrices, which is used for all of the above. After that, I imported the confusion matrix classification report. After that, I imported the plot precision recall curve and ROC, AOC score and ROC curve. First model I used is the logistic regression to predict the model. First of all, I imported the model which is present in the linear model in sklearn library. So I created an object for it and I trained the model by giving you two parameters. So I predicted the way I predicted the model. I predicted the values and printed it. So these were the predicted values, and I also calculated the score accuracy, which accuracy comes out at 56%, which is not that good. This is the classification report which gives all the precision, recall, and F1 score. Here you can see in macro average 0.55, which is not good at all. And here macro average is just an average of these two elements. And I plotted the confusion matrix in the heat map. Uh, so as you can see, F1, Fn, false negative is so too much and false positive is also there. So it can't be considered as the good model. So after that, I plotted a precision recall curve, which says that area under which has only area under the curve is only 51%, which is not good. Here, uh, precision recall curve, we can say that higher the precision, lower the false positive rate, and higher the recall, the lower false negative rate, and the precision recall are always inverse to each other. Next one, I plotted the ROC curve, and this is ROC curve, and area under the curve is only 0.53, and which is not that good. Next one is I used the Naive-Bayes algorithm. I imported the Naive-Bayes algorithm, which was present in the Naive-Bayes module in sklearn library. The same way, the same thing I did with the logistic regressions, all of the above, and predicted the accuracy, and accuracy comes out to 55%, which is not that good. And here also macro average is for 0.54, not good. Next one is the KNN algorithm. In this scalar algorithm, I imported the model which was present in the neighbors module, and in a sklearn module or as a library, I created the object for it, and I trained the module, not trained the model. Next one, I printed the predictions, and after this, I calculated this accuracy, and accuracy comes out to 84%, which is also good. Uh, so, and here you can see that plot precision recall curve plots the graph like this, and which covers the area about 0.76, which is not good also. So, and this is the ROC curve as a 0.84. It can be considered as a good one, but for a surety we will use more models. And now I use the SVM algorithm same way as I did with the all other algorithms. Accuracy comes out to 55%, which is not good. This is a decision tree. I imported the decision tree from the import tree module, which was present in the sklearn library, the same way I did with the logistic. And accuracy comes out to be 86.7%, which is good enough for predictions. And this is the classification report, which gives the precision recall and F1 score. Macro average is the 0.88 and 0.86, which is good enough. and this is the heat map. And here you can see the false negative is little bit low, 81 only. And this is a precision recall curve in which 0.994 area is covered. And this is a ROC curve in which 0.86 area and the thing is 0.86. And random forest classifier, it gives the same accuracy as a random forest classifier. And decision tree 86%, and here also this is random forest 86%. But we should use random forest because it gives more precise answer, precise predictions. So here you can see 61 were the on, which is only 61 were there false negative. Next one I plotted the ROC, which is which gives a pretty good curve, and area under this curve is 0.95, and for the ROC curve also is the 0.86. And these were the predictions I did. I imported the test model for the predictions, and these were the first 5 elements. The same way I did before. I consider team one as 1 and team two as 0. After that, I converted the winner into the binary variables. These were the some unique values. I dropped date, winner, and winner binary because I just want the inputs only, and this is the outputs. Now I replaced all the teams with the team's name. Team's name is the Hi. You can see teams one is the Mumbai Indians, which is converting into a numerical value. So I converted all the teams into the numerical values. So like this, and these were the top five elements of the input values team 1x. And after that, I predicted predicted the values, and outcomes comes to be 0 and 1. So accuracy comes out to be 87%, which is good enough. So I decode 0 and 1 is not that we can't say that what is 0 and what is 1. So I decoded the 0 and 1 into categorical variables. So this is the final outcome. So now I will tell you why I did this. Why I did this because um, as as you can see in this graph, in this the confusing matrix comes out to be 13 into 13, which is a multi-class, and we can't even plot the this ROC curve, which tells that a multi-class format is not supported, and we can't also plot the precision recall curve. So to solve this problem, I converted the winner into winner binary. It will not change my accuracy at all. It gives the same result. So that's all about my PPT, and at last we can conclude that random forest can be used for prediction, and that's it for all. Thank you.